This was a question from computer organization topic regarding reading from caches. Now the question text was very large, so I have written the summary of the question here. To refer to the full question text, please refer to the question paper itself. Now the question I will explain here. In the question, they were giving us a single level cache. Okay, and the size of the cache block is 8 words, and the size of one word is 4 bytes, and the CPU clock frequency is 60 megahertz. So in order to service a cache miss, the processor takes one cycle to accept the starting address of the block. It takes 3 cycles to fetch all 8 words of the block, and afterwards it will transmit words of the block at 1 word per cycle rate. What is the maximum bandwidth for a series of read operations? Dash into 10 power 6 bytes per second. What this is, that's what we need to answer here. So in this cache organization, they are saying that in order to service a cache miss, first it will take one cycle in order to accept the starting address of the block, and after that it will take 3 cycles to fetch all the 8 words of the block, and then afterwards it will transmit the words of the block at 1 word per cycle. So in order to transmit one cache block, what it will take is one cycle first, that is accepting the starting address of the block of the cache block, 3 cycles in order to fetch all the 8 words of the blocks, and after that additional 8 cycle. 8 is for transmitting words of the block at 1 word per cycle. So it will take 1 cycle per word. A cache block has 8 words, so it will take total 8 cycles in order to transmit all the words. So if you see, it takes a total of 12 cycles for 8 words. 8 words because there were 8 words in one cache block, which means it will take 32. It will take 12 cycles to transmit 32 bytes, because one word was 4 byte. Therefore, 8 word size will be 32 bytes. So in 12 clock cycle, we can transmit 32 byte, which means bytes we can transmit in one clock cycle is 32 by 12. So that's the average. So in 32 by 12 bytes is what we can transmit on an average in one clock cycle. Now the frequency is given as 60 megahertz, which means in 1 second there will be 60 into 10 power 6 clock cycles in that CPU. So if this is the data that is transferred in one clock cycle, so the data that will be transferred in 1 second will be the data transferred in one clock cycle multiplied by how many clock cycles are there in 1 second, that is 60 into 10 power 6, and bytes per second, that is the data that will be transmitted. So this is nothing but 160 into 10 power minus 6 bytes per second. They were asking how many into 10 power 6 bytes per second we could transmit. The answer is 160.